We're going to start thermal expansion. So what happened, let's suppose we have some object, a metallic rod that we are heating. When we provide the heat to this metallic rod, what will happen? The atom of this metallic rod, they get the kinetic energy, and that will increase their motion. So they will start vibrating more frequently, and they are going to knock into each other. So due to the high kinetic energy, they knock into each other and push each other apart. So this pushing force will cause the expansion. The overall size of the object will increase, right? So this phenomena is known as thermal expansion. So what we have to consider that in thermal expansion, it's the space between the molecule that increases. The molecule themselves remain same. The size of the molecule is not going to change. Okay, so when we draw a comparison for solid, liquid and gas, the gases expand most, then liquids, they are intermediate, and solid expand least. This expansion is because of the binding energy. Solids have maximum binding energy, so it's very hard for them to expand. And gases are freely moving, they have negligible binding energy or no binding energy, so they can easily expand. So when expansion occur, these are the consequences that we can face. The expansion of solid material can cause them to buckle if they get too hot. This could include metal railway tracks, road surfaces and the bridges, right? So things those are prone to buckling in this way have gaps built in. This creates space for the expansion to happen without causing any damage. So we commonly see in bridges and metal railway tracks there are gaps between the different tracks, so they can allow the expansion without causing the buckling effect. Okay, so what are the applications of the thermal expansion? First application is the thermometer. So liquid thermometer is made up of mercury and it's full of mercury and in a glass tube. Thermometer that uses the expansion and contraction of liquid mercury to indicate the temperature, right? That is called mercury thermometer. So let's suppose if there is a low temperature, the liquid, the mercury will be till that level. When there is a high temperature, these molecules will expand, they will knock each other and expand, and the level of the mercury will rise, and we can easily measure the change in temperature. So we relate the expansion of the liquid with the temperature, right? This is the first application of expansion. The second application is the bimetallic thermometer. What is bimetallic thermometer? A bimetallic strip consists of two thin strips of metal that are typically brass, copper, or steel, right? You can use different metals, but these are the typical metals those are used. So the strips are layered on top of each other with one end joined and the other end are free, allowing the assembly to bend and respond to the temperature changes. So if we see this, these are the two strips. We can see one is here by the, this is strip 1, the green one, and yellow one, this is the strip 2. Okay, so that is what is called bi mean 2, and it is made of the metal. So when there is a expansion, when there is a change in temperature, this metallic strip will bend and it will make a contact with this thing, right? So if you see, there is a wire, there is a wire, and this strip will provide a continuous connection for the current to flow, and it can switch on or off the circuit. So that is the second application of thermal expansion. So this is all for thermal expansion.